Now, I believe I mentioned how high my parents put this board, but I think they put it like so high that we had to like adjust our camera so high that like you can't even see my Math Kids shirt. Like, here, now can you see it? No? Well, now can you see it? Good. Now let's get back to the problem. Ivory writes down 3 two-digit numbers, each with units digit 7. The tens digit of the product of these numbers is 5. What is the tens digit of the sum of the 3 numbers? Now this is only for MathCounts, but I believe this is one of the hardest things I've taught at Math Kids. So it's probably okay if like your mind goes blank, but it took me a while to learn this actually, but anyways, you can think about this as, well, tens digit. Say the tens digit is A of the first number, well then the value of the tens digit in the first number would be 10. Again, A is the tens digit of the first number. And we have the unit digit 7 at the end, and the unit digit of the 7 is just 7. So that's the tens digit. So the product of these numbers, well, what is these numbers? Well, that's the 3 of the numbers. So the second number can be 10. B, and B is the tens digit of the second number, plus 7. And it's not unusual that the third number is 10. C plus 7. Okay, so now that we have this, well, here's the product of the 3 different numbers. Now, I'm not going to go ahead and multiply like 10a times 10b times 10c and all that. It's sort of complicated using the distributive property to do this. Now, so I'm going to think about 3D solids, and it's going to be a little more helpful in how this 3D solid help us do a lot less work on computing this. So anyways, make a 3D solid rectangular prism to be accurate. And I think it's a little skinny, but okay, there. And this rectangular prism, well, that's not for nothing. We're including these 3 numbers in here. These numbers are like dimensions for a rectangular prism. We can call this dimension down here 10a plus 7. You can call this dimension up here the height of 10b plus 7. And I can call this dimension right here, that's the depth, 10c plus 7. Now, to compute the volume of this solid, we're not just going to multiply 10b plus 7, 10a plus 7, and 10c plus 7, which is exactly what that is. It's trying to make us do, and we're not falling for that trick. We're going to do this a lot easier by kind of splitting this part up into 7 and 10a. So, now that we've cut this up, we're going to do the same with the other 2 dimensions. Here we're going to cut this up into 7 and 10b. And then, similarly for here, cut this up into 7 and 10. So, now this is getting a little messy, so first continue all these cuts so it looks a little more symmetrical. There. So, wait, forgot about that one. You see that there are 4 of these little pieces in the front and those 4 pieces on the back, so basically that makes 8 pieces. Now, that's not what we're trying to focus on. What we're really trying to focus on is the fact that we only care about the tens digit, right? We want the tens digit. They give us tens digit of the product of these numbers as 5. So we only care about the tens digit. So the tens digit of this, well, think about this a little bit. we just need tens digit, right? Well, the tens digit doesn't matter. The tens digit of a number doesn't matter if the tens digit is 0, right? So we don't care about the products or the volume of the pieces if we're thinking about the 3D solid still. So we don't care about the volumes of the pieces that have tens digit 0, right? So basically, 10A times 10B times 10C, which is one of the parts we'd have to compute if we didn't think about this 3D solid stuff. Well, if we did compute 10A times 10B times 10C, then we had the 10 times 10 times 10, which would make 1,000 times the A, B, and C. So, well, these A, B's, and C's, they don't affect the tens digit of our number, right? So we still have 1,000 something, 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 right? All these is to change the number to 1,000, right? I'll just change this little number right there to be 1,000,000. And the tens digit is still 0, right? It doesn't matter what this A, B, and C does. So basically the tens digit of this number, that will be 0. And zeros don't count in the tens digit, right? So we don't care about this little part. And nor do we care about if we had 10A times 10B times 7, right? Because then we would have 100 times A and B. Well, that just changes the number of 100s. So we would have, like, let's say, I don't know, 900. But, so the tens digit of 900, well, that's 0, right? And the 7 doesn't change anything either, right? We just change, like, 6,300. That's 7 times 900. But, you know what I mean, right? The tens digit will always stay 0. But what we do care about if there are 2 sevens, right? Because 2 sevens, well, that's 49. The tens digit of that is 4. So no matter how many like tens we add to the 49, that's not going to change. Well, that's a little complicated because it is going to change tens digit eventually. So just think about it like this. So we have these 2 sevens. 7 times 7, those 2 sevens. Well, then after we pick the 2 sevens, well, we need another one of these from here. Let's just say we pick 10C. Well, then we have 490 times the C. And similarly, if we have 7 times 10B times 7, then we have 490 B. And of course, we also have the 490A where we pick 10A 7 times 7. So to do this, we can kind of do a little factoring thing. 490 times A, B, and C. Now, let's see. Well, these 490 A, B, C, they're not the only thing that don't have tens digit. I mean, that don't have a tens digit of not 0, right? We could have picked 777, but that's the only other thing, right? We can only have 7 times 7 times 7. That's the only other part, the only other piece in our 8-piece solid that doesn't have a tens digit of 0 in its volume. So we have to add on the 7 times 7 times 7, which is 7 cubed. Okay, now this is getting a little complicated, even though we haven't done much writing on the board. Because this problem, it does not involve any calculus, okay? I am assuring you. No fancy things like all that in this. Just simple algebraic equations and expressions. There's not even any equations. Just that it's hard to think of these expressions if you think about it. I mean, you have to do all this 3D solid stuff, and then you have to notice the fact that 10A, 10B, 10C, that we don't need that part and all that. So it's pretty complicated, even though we haven't done much on the board. Although my throat is getting kind of sore, and it's probably gonna get more sore at the end of this video. But anyways, I wonder how long this video is taking. I don't know, but probably a little more than like 10 minutes or so. Anyways, let's get back to the math. So, well, we see this A, B, plus C. A and B and C. Well, A and B and C, those are the tens digits of all these numbers, and well, I'm excited because we want the tens digit of the sum of the three numbers. A, B, C. That's the tens digit, right? Those tens digits are really all we care about, right? Tens digits. So now I'm like really excited. So if we could just figure out how to use this equation and get to our answer. Now, I don't see how to do that right now, but at least I can keep making little itty bitty steps towards the answer. Now, first I'm going to deal with the 7 cubed thing of the 490 times A, B, and C. Oh, 7 cubed. 7 squared is 49. 7 times that 49. Distributive property, that 40 times the 7 is 280. And we have the extra 9 times 7, which makes 2. Wait a minute. That's confusing, actually. So, forget about that. I probably said something wrong, because how would be... Never mind. That's definitely probably said that wrong. So, and I kind of confused myself. So let's just use multiplication algorithm. That is impossible to mess up on. Whereas I've been practicing for a real long time. So, sometimes 10 is 63. 4 times 7 is 28. Plus this 6 is 34. And I have this answer. Feels a little more familiar, so I'm pretty sure I'm right. So anyways. Okay, hopefully I didn't make a mistake there. We can move on. 343. Now let's go back to our tens digit thing. Well, still, remember, this is still just a fancy way, just a different way of expressing the tens digit of the volume of the entire solid. So, basically, that's the product of these three dimensions. So that is 5, right? So we already have a tens digit of 4. So we need this entire thing, 490 times A plus B plus C, that we need that entire thing to be unit digit 1. So you can have 4 plus 1 equals 5. So, now that we know that, well, we already have a 490. So we need this A, B, and C, and A, B, and C. You know why that's important. So, anyways, we say the only way that 490 times is something, this A, B, and C, well, the A, B, and C, that has to have a units digit of 9. If you think about it, like, if you don't believe me, you can, like, try a number, like, we have something that has tens digit 9, just forget about the 400 part. This a number with tens digit 9, right? Say it's just nice and simple. And then this A, B, and C, let's say some of that is 9, right? Units digit 9. 9 is a number with units digit 9. Well, then 9 times 90, that's 810. So, and that does end in, the tangent of that is 1. And you can pick other numbers with, like, tens digit 9 and units digit 9, and you're still going to get tens digit 1 no matter what numbers you pick that follow those two rules. So anyways, hopefully I proved to you that my instinct was right, that this stuff has to have a units digit of 9. Okay. How does that help? We have a units digit of 9. I wish that was 10 digit, but no, that's not right. That's not a 10 digit. That's a units digit. So, how do we move on? Well, think back to this product and 3D solid and how we're supposed to find the sum. Kind of another piece of work. Well, let's see. You see, basically, the sum of all the tens digits, the value of the sum of all the tens digits, I mean, when we do care about the value is like 340 and the tens digit is going to be 40, but that doesn't really matter. It's going to be 10a plus 10b plus 10c. And, well, we have that, actually, like, each number has a unit digit of 7 thing. So that's 21, which is 3 times 7. 7 plus 7 plus 7. So, well, we can kind of factor this 10a, 10b, 10c thing by doing 10 times a plus b plus c, and we still have that 21. Well, we already know that a plus b plus c, we already know that that has unit digit 9, which is basically what we figured out here. So if a plus b plus c, that has unit digit of 9, well then unit digit of 9 times 10, well then the tens digit of that is going to be 9. Tens digit of that is 2, so we take the tens digit of 9 and tens digit of 2, add those together. Well, we go up first we increase the tens digit of 0, and then we go right back to 1.